Good afternoon and welcome to today's FasTech seminar featuring 3M. During this session, David Foresyth, Global Product Portfolio Manager for 3M, will discuss TwinAx Cable solutions for high-speed applications and industrial connector products. Everyone is muted, so please feel free to type any questions into the chat for this Teams meeting, and David will address those questions at the end of the presentation. I will also be recording this seminar. Unfortunately, we missed a few minutes at the beginning of the event, but I am including those slides, and I will send the slide deck to everyone who attended. And now I'll turn it over to David.
By Equinix, and they're trying to measure the interconnectivity index and what is driving the high bandwidth. And when we look at that, their metrics are above a 44% CAGR, compounded annual growth rate, for the overall interconnectivity of the industry. And that is split between service providers that provide services for telecommunications, cloud and IT services, as well as hyperscale providers, Microsoft, Amazon, Facebook, Alibaba, Baidu, companies like that that are really driving high demand in devices as well as high bandwidth in data and services. And then on the enterprise side, your traditional enterprise companies like an HPE or a Dell, and then the banking and trading services that they represent and service, as well as manufacturing, are the top three opportunities in enterprise. Again, greater than 40% CAGR for those top three. So again, this is just data validating that the industry is moving towards being interconnected and driving high bandwidth data to service various vertical segments and ultimately the needs of the consumer. So as you saw from the data from Equinix, as you saw from the roadmap from the PCIe standard, there's a doubling of bandwidth roughly every 3 years. And so as you look at that in the generations of PCIe, you see that there's a release of the specification and then a lagging of the actual bandwidth increase for the devices that consume that capability as new devices are developed and launched. And today we're seeing, if I recall correctly, Intel actually releasing some of the Gen 5 capable chips. So we'll actually see in the next few months release into the market a flood of server devices capable of Gen 5 speeds. So this is really exciting. Many of us in the industry have been working on this for the last year and a half, 2 years. And now that we have Intel support in the market for commercial CPUs, many of us will see the benefits of that with greater adoption of product and services. And then Gen 6, that was released last year. And with that release, we would anticipate in another 18 to 24 months, the devices supporting that, as well as CPUs supporting that, being released into the market. And then in 2025, we see Gen 7 planned release for the specification from the PCIe SIG group. And with that, again, a doubling of the bandwidth of the connection specification. And in case you didn't know, I didn't mention this and probably should have at the beginning. PCIe SIG, this organization is a special interest group of over 800 companies that collaborate and set the specification for the I/O bus so that there's interoperability of all the devices from various manufacturers. And as I show in this next chart, not only interoperability of devices from various manufacturers to a common spec, but also interoperability of various generations of PCIe devices. So each generation, each new generation, is backwards compatible with the older generation. So if we take a look at this somewhat busy table here and take a look at the two columns on the right, the by 8 or the by 16, if that device is designed to perform at PCIe 5, so this lower section here, 64 gigabytes per second or 128 gigabytes per second for a by 8 and by 16 respectively. If that device is then plugged into a slot that's only designed for PCIe 4 or PCIe 3, the speed of that connection will then default to the lowest speed within that interconnected system. So that Gen 5 add-in card, if it was plugged into a Gen 4 or Gen 3 slot, would only support 32 or 16 gigabytes per second. So something that designers keep in mind as they look at systems and the value of that for OEMs and device makers always being compatible with the latest generation of spec is what has maintained the relevance of the PCIe SIG specification. So to address this market trend of roughly doubling of speeds every 3 years, 3M's developed a 3M brand twin axial cable, and that cable is then built into cable assemblies that can connect the motherboard to the peripheral device. And that typically is motherboard to a backplane or an add-in card. And what our cable allows the designer and the device manufacturer to do, as you see in the right here, is to bend and fold and route our cable in very dense confined spaces. The silver area is a GPU or a CPU, and the black area here that you see is a DIMM, and you can see between that, and you can probably relate to your own designs, there's not a lot of space here. And so what we can do is bend and route, fold our cable, very sharp angles, and we will not compromise SI. And we can also maintain airflow. So you can see that our profile is parallel to the fans, front to back in this picture, and it maintains airflow. So we're not blocking the cooling fans from cooling the DIMMs of the CPU. So the value in 3M's cable assembly here is supporting these dense environments for interconnectivity without compromising performance, either in signal integrity or in thermal management. So when we look at the 3M brand twin axial cable, that's the cable in the upper right of this picture in the slide. And that cable you can see has a longitudinally laminated shield, this silver color here. And that's precision laminated around precision formed high-speed pairs that you see here, here, and here. And that allows us to create a uniform shield so that when you bend and fold the cable, we don't compromise the SI performance of the cable assembly. And so that's the significant difference of a 3M twin axial cable versus the two cables that you see below, which are typical high-speed pairs that are then spirally wrapped or longitudinally wrapped such that the shielding there creates a thicker, less flexible cable. And when bent at sharp angles and folded, this SI performance is compromised. So the advantage here of 3M is in the shielding and the precise manufacturing of our cable that allows us to bend and fold our cable without compromising the SI performance. So how do we implement this cable into something that the industry can use? So we do this by integrating our cable assemblies into a form factor, a connector that then is maintained to a specification, as you can see in the lower section of this table. So if we start on this table, the slimline assemblies here, which are designed to the SFF 8654 specification. The first embodiment here is a standard connector. And 3M, through the request of customers, has created two versions of this, a mini slimline and a compact slimline, both changing the dimensions of this overmold to be less high, so reducing the height, and in this case, reducing the width, so that the designers and architects can pack more connections into a 1U or a 2U server and increase performance without increasing the size of the server needed. So we've changed the physical footprint of the connector, but have not changed the physical footprint of the PCB, and allows us to still meet the performance specification of the SFF 8654. In the generations of the cable assemblies, you can see the speeds that we support on the SAS 3.0, 4.0, as well as 3 and 4 PCIe, and that's the earlier versions of Slimline. And you can see with Mini Slimline and Compact Slimline, we're able to increase the performance of these form factors to PCIe 4 as well. We have not launched a SAS version of this at 100 ohm, but ideally it would be possible to make these connectors with a different impedance and then measure them against the SAS specification. So then if we proceed further to the right side of this chart, the low profile IO assembly here is designed to an industry compatible connector that you see here. It's available in a by 4, a by 8, and a by 12, and is compatible with systems designed to PCIe 3 and PCIe 4. The next two connectors that I'll describe here are the multi-channel I/O, and that's designed to the SFF TA1016 specification that you see in the bottom row, and that supports PCIe 4 and PCIe 5. So the faster speeds that were launched in recent years with PCIe 5 in 2019 are supported by the multi-channel I/O. And what this allows us to do is support the higher speeds with the minimal impact on the form factor size here. So you can still densely pack this form factor into a 1U, 2U server and to have the performance benefit of a PCIe 5 specification. The next connector that I'll mention was formerly known as a Gen Z form factor, a 1C, 2C, or a 4C. And that has now transitioned to the PCIe SIG group and is the SFF TA 1020, or some might know it as 1002. There's a family of specifications for this connector. And this is a little bit larger than the multi-channel I/O dimensionally in terms of the black housing and the form factor of the connector. The PCB form factor changes as well, which allows power to be delivered in this form factor, which makes it ideal for adding card applications. And so with the minimal change in size, with the addition of power and the benefit of PCIe 5, this seems to be a great opportunity for adding card applications using this form factor. So we see applications not only for connector to connector, a multi-channel I/O to multi-channel I/O, or a Gen Z to Gen Z, but we also see applications that are incorporating the PCIe extender with the CHEM connector. So the CHEM connector itself, 3M has a product that is an extender that just has a male and female end that allows, you'll see in a later picture, the designer to move this card electrical mechanical connector from one portion of the system to another and still maintain performance. So this cable connector is another way to move the adding card or a GPU to another portion of the device without compromising performance. And then what we're seeing in some designs for the industry is an incorporation of this Chem by 16, either with a Gen Z or a SFF TA1020 connector or a TA1016 connector, so that you have the benefits of connecting to the motherboard with the Chem by 16 and then the mid plane, back plane, or device with the higher speed connectors. So once we have this base family of connectors, depending on the design and architecture, there's a number of ways that we can implement this in a product format for a customer. So I mentioned earlier in the application for the extender. So PC gaming, many of you may or may not be familiar with this, but PC gaming during COVID really took off as an opportunity for those of us that were staying at home to pass the time with either building a PC gaming rig or supporting a friend or relative that was building one. And you can see that the GPU that's placed here at the bottom of the unit allows you to move that GPU and not compromise performance. So you can see in the exploded view a PCIe extender plugged into the motherboard, and then the receptacle allows you to plug in the card outside of the motherboard, not perpendicular, so that you can really show off the LEDs or the brand, or customize how your GPU looks in this PC gaming unit. And that, as you can see by the LED fans in the front and the rear, as well as the cooling fan in the middle, the colored LED of the keyboard is really an important customization and personality of each individual gamer in this industry. So great opportunity here to showcase the highlights of high-speed performance with the flexibility and speed of a 3M brand twin axial cable solution. High-speed test equipment, as the industry has moved to higher speeds, there's the need to test, and the 3M products with the cable assemblies, you can see here the extender, but our cable with its high performance, low loss, are well suited for high-speed test equipment. You saw in the earlier illustration the use of our cable in dense computing environments, typically in an HPC environment where you're using GPUs, the limited space and the interconnectivity required really is a great application to use a 3M brand twin axial cable assembly to connect your motherboard to any type of peripheral within your system. And then the last application I'll cover here, more traditional in a server and a computing environment. As the industry has moved from SAS and SATA to NVMe, the number of lanes required to support that has increased, and there's still the standard architecture of connecting to a mid plane. So using some of the form factors that I reviewed in the earlier table, the low profile I/O, the multi-channel I/O, or the SFF TA1020 form factor, you can connect those devices now to the motherboard at the higher speeds PCIe 5 and not compromise performance when bending and routing in a dense environment. So that concludes our internal overview of the specification, the market, and the 3M products and technology associated with that. So I'd like to now transition to our 3M brand twin axial external cable assemblies, which are our direct attached copper cable assemblies. And so these cable assemblies are designed around the IEEE specification 802.3XX, and then the XX is replaced by each of the specifications that you see on the table on the right, which increases the speed of the data transmission from 40 gigabits per second to 800 gigabits per second. And with this, we see with the table, the graph on the left, the transition of switch speeds and switch revenue from 100 gigabits per second to greater than 400, really in this time frame that we're talking about, 2023, where we see 100 declining, 200 was really never adopted in high volume, and 400 and 800 being adopted now, and then 1.6 and 3.2T being designed now for generations of server architecture in about 2 years. So the 3M brand twin axial external cable assembly has many of the same benefits of the internal cable assemblies. You can see here in the lower portion of the picture that our cable is flat compared to traditional cables, which are round, but that allows us to bundle the cable, move them out of the way here that you can see, and creating more open space for airflow. It allows us here to open up the airflow in front of the fans and allow easier access for serviceability. So you can see here that instead of having the silver jacketing outside, we've created and have extruded a over laminate so that the cable is protected from damage in the rack connecting the NIC to the switch. So again, many of the same physical properties of the TwinAx cable are translated here and benefit to the external cables. Thin, flexible, bendable without compromising SI, and still improving and maintaining thermal performance. When we look at the table of products, this is a much smaller table that I put here. We do have additional product offerings, But for the sake of industry adoption, you can see in the middle the 100 gig product using the QSFP28 form factor, available in a straight cable, a Y cable, and bifurcated cable. And then you can see on the far left, a 400 gig QSFP DD form factor that supports 400 gig. And that's available today, and customers are using it. And we're also looking at developing an 800 gig version of QSFP DD as well as OSFP. So this is a brief overview here of the 3M DAC portfolio and what's available for immediate development or evaluation. Where would we use these DACs? When I mentioned the data centers, cloud computing, fog and edge computing environment, the servers are typically put into a rack. Those racks are then put into rows, and each of those racks is a very dense environment, similar to the server being a dense environment. So there's many DACs connecting each of the servers to a top of the rack switch, and then that top of the rack switch is then connected to the next level switch. So using the 3M cable for the direct attached copper cable assembly, you can bend it, you can fold it, you can route it in that limited space. And because it doesn't have a minimum bend radius specification, it allows you to fold it inside that dense environment into the physical space and actually close the back of the rack door. And so typical round cable constructions have a uh, minimum bend radius specification. And when that specification is adhered to in a high cable dense environment, you would typically not be able to close that back door. And so if there's a high security area where the server needs to be protected in a secure environment and you can't close that door, 3M's cable assembly would provide that feature as well as the SI benefits and allow you to have a more secure rack environment. So with that, that concludes the presentation today. I'd like to thank you for your time and interest in the 3M product, and I'll open it up for any questions that you might have. My team here has been monitoring the chat, and if there's any questions, please feel free to let me know, and we'll try and answer that.
Mark, we have
Dave,
a couple minutes. I'm sorry. Go ahead.
I was just going to say one question that was asked and that I responded to in chat was whether hybrid assemblies using different form factors on each end are available. And I did answer that in chat that definitely they are, including fan out assemblies. If you consider like a by 8 fan out to 2x4s, you might consider that a hybrid assembly. Those are available as well. Another question I was just preparing to answer was concerning whether custom lengths and or a folding and taping of assemblies is available. If you want to take a stab at that.
Absolutely. And that dovetails into the earlier question or the first question that you mentioned, Mark. So the matrix of connectors that you saw for the internal cable assemblies can be mixed and matched together to create hybrid assemblies, really depending on what kind of backward compatibility you might need in your system. So you might have a slimline with an MCIO. You might have a chem connector with a TA 1016 or a 1020 in what we might call a hybrid. And then each of these, depending on your network architecture, will have custom lengths so that you can custom route and tape them. And what we would do is work with you on what those specific dimensions are. And what we would actually do is work with you on a prototype, bend, fold the cable, help you route it, and then produce those prototypes based off of the early paper folds, and then actually create the assembly so that you can plug it into your server. So absolutely, we can do that. Any other questions?
Mark, would you like to cover the question from Jim? I think you're muted. Well, Jim, actually the answer is in the chat. But what I can do, since we are at the end of our time, I will pull the questions from chat and add those to the message I'm going to send out with the recording in a couple days, so everyone has those questions and the answers as well. Okay.
Thank you very much, Robin, and thank you again, everyone, for your time today.
Thank you, David, and thank you everyone for taking the time. I will be sending the slide deck out as well with the recording link. But if you have any questions or would like more information about this topic, please reach out to either me or your field sales representative, and we'd be happy to help you. And also, we have a poll that I launched. If you wouldn't mind responding to that poll in the chat, that would be great. But otherwise, I again appreciate everyone's time. Hope you have a wonderful day. And thank you.
Thank you all. Bye-bye.
Bye.